morning, students. So my name is SP Jani. I am Associate Professor of Department of Mechanical Engineering, Mlritm College, Hyderabad. So now in this series, I am going to teach you additive manufacturing technology. Is an important manufacturing and ever-growing manufacturing process in the mechanical industries. So first we are going to see about what are the different type of contents I am going to deliver today that I am seeing. So industry revolution. So what is the reason we are using this additive manufacturing and how this additive manufacturing is came to the picture of the industry. And the second one is fundamentals of fabrication process. So already we studied in the MMT and production technology subject. So what are the different types of fabrication process is there? What are the different types of machining method is there? What is a conventional machining process? What is unconventional machining process? We study in UCMP subject. So apart from that, what are the different another manufacturing is there? That also we will explain in this second one. And third one and fourth one, what is additive manufacturing? So in there only we are going to study about what is additive manufacturing, what is the definition, how the additive manufacturing was grown in the industries, and if you want to process the additive manufacturing or if you want to make any develop or any developed product in the additive manufacturing, what is the process we have to follow? That means step by step procedure, what are the things we have to follow? That two things we will be studying these two slides. And we have to study about we are going to study about the another one topic that is very important, RP, that means rapid prototyping, 3D printing and additive manufacturing. So in that industries, or if you are going to any market, everyone is talking about the additive manufacturing or 3D printing or rapid prototyping. So what is the difference between, what are the difference between these three? We will study in the next topic, last slide. Then one or two examples I will show to you. Then you can able to understand the things. So first, in that order, first we are going to see about the industry revolution timeline. First thing. So our manufacturing industries was developed in 1987. First. Okay. So in that time only first our product development means by using some engineering mechanism we developed some process. So that was happened in 1987. So that we can tell about we can say about industry 1.0. That is we can call as the industry 1.0. And in the during this time, what are the important things was happened? So mechanical production equipment driven by water and steam power. So basically I said, so by using some basic engineering mechanical mechanism, they were developed, they were produced the steam power. Okay, so by using the steam power they generate the power, electricity. So in that way it was happen. And coming to the next revolution, that is industry 2.0, second industry revolution. So in that it was happened 1870, that is important timeline. So during that time, in all the industries, manufacturing industry, they have used the belt conveyors to handling the this is belt conveyor. Okay, so here they use the belt conveyor for material handling or one place to another place, picking the some product from one place to another place. That thing they used. And not only belt conveyor, they used some chain related conveyors also to transfer one place to another place material as well as product, developed product. If you want to send some developed product to the assembly section, they used this kind of mechanism. And this mechanism is used to this mechanism was run by some basic chain mechanism as well as pulleys, like the things. So when they entered to the third important, this is third very important revolution happened in this industry. So automation, little bit automation was came to the picture. So in that by present the pick and place robot, main thing is pick and place robot. This is the pick and place robot. This is important thing. So pick and place robot, what they used, so material handling. So in the second revolution, what happened? This all the materials was came near to the our any machines or any product development place. From there, by using the manual handling equipment, they manually they handle and they kept in the machine area. But in this third revolution, not like that. In the third revolution, automatically this by using the belt conveyor or whatever any material handling system in this third revolution. Another one important thing happened, material handling purpose they use some robots also, like line follower robots or edge detection robots. By using it will be transfer one place to another place the material as well as products, developed products also. For the assembly section, if you want to send, they were used some robots configuration. So in that, after sending the material one place to another place, it will be reached to the near to any other machines. So machines or any floor, any shop floor. So there we don't want to keep any manual or any human being there. So by using this pick and place robot, automatically it will be pick from the robot, and it will be placed in the automatically it will be placed in the machine. So there only machine setup and initial setup process and machining process only human side we have to change, we have to do it. And one more important thing in that mechanical, in this period only, in CNC machines was developed, NC machines was developed. These two very important, because by using these two technology only, present days industry 4.0 also we are running. Okay, this is the basic things, CNC or NC programming control. So in that PLC also came, PLC program logic control. So this all introduced in the industry 3.0. So one of the biggest revolution happened after almost 200 years, almost 2 century. After 2 century, we reached this industry 3.0. So after 3.0, and we entered into the industry 4.0. Okay, fourth revolution. So this fourth revolution, so nowadays present industries, what are the things or what are the automation process they are doing, that things comes under the industry 4.0. So what things has happened here, no need to any human beings. So in the 3.0, at least from the initial machine setup or any feedback control, any mismatch, that feedback modification and everything, we have to use the any human. Okay, but coming to the fourth industry 4.0, we no need to use any human. Automatically already the program has inbuilt in this our software. Based on the thing, it will be give the command to the this pick and place robot or whatever components if you are using for material handling purpose or any machining purpose. It will be give the command, and it will be give the optimized solution, optimal value it will be give. For example, optimal value, what is the optimal value means? For example, you can take the lathe machine. So in the lathe machine, we have number of components in that. If you want to make any machining for, or if you want to do any machining or taper turning or like that any machining process, we have to set some initial parameters to that machine. What are the initial parameter we have to do? For example, depth of cut we can do, and feed rate, as well as lubricant flow rate. So like that, some initial parameter setup. Again, speed we have to give. These are all important parameter to which is used for running the lathe machine, normal central lathe. I am talking about normal central lathe. So in that we have given sometimes we have to given for some material we have to given 200 rpm speed, and liquid lubricant flow rate we are giving maybe 5 mg per second, and feed rate maybe 2 mm we are giving, depth of cut 1 mm we are giving. So this is all we are giving to machine, this initial setup, like initial setup we are giving. But coming to the industrial 4.0, if you are entering, okay, this is our material type. So material type, if you are, this again once again I forgot to say. So here if you are using some different materials, so for example this setup we have to use for normal MS. Okay, so after that I'm going to change the material. Suppose HSS I am going to do, otherwise any plastic material, otherwise any rubber like that material, or any lightweight like aluminum material if you are doing, again we have to change this all the setup to the machine. Okay, but if you are coming to the 4.0, just you have to say, you have to give the input, our material is rubber material, or our material is plastic material, or our material is MS material, or our material is HSS. Like that, if you are say, automatically it will be give the these parameters. It will be give the these parameters. What are the parameters? Or depth of cut, or speed rate, or lubricant flow rate. These all parameters automatically it will be feed to the machine. We no need to give any initial setup to there. Automatically it will be feed. Based on the feed, this machine will be give the output, and again it will be take the feedback from that machine. Any problem is any surface finishing product, surface finishing problem, or any MR related problem, material removal related problem, if it is there, again based on the feedback it will be give again optimal solution. Again it will be change the these parameters. Then automatically it will be feed, again it will be feed to the machine, and it will be run continuously. So there we know no human effect is zero. That is the important thing there. Then next important, so this is the complexity. So if you are seeing from industry 1.0 to 4.0, the complexity of product development or complexity was increased compared to first. So first complexity is very less, if you are seeing here this graph, and second one is compared to first one it is somewhat more, and third one is moderate, and fourth one, if you are seeing, there is a lot of different. Okay, so complexity, degree of complexity is very, very, very high. Okay, so next, okay, so here I am going to teach about the fundamental fabrication process. So what is this? So here I am going to you are seeing three different types of process. One is subtractive, another one is additive, another one is formative. So in that manufacturing industries, entire world, we are following these three different types of method only to make any product development. Okay, so one is subtractive, another one important thing is formative, and present growing technology is additive manufacturing. So what is subtractive, sir? So subtractive, by using any machining, that is NDT or any MTT. Okay, that means machine tool. By using any machine tool, or by using any unconventional machining process, whatever process we are doing, that is comes under the subtractive machining process. Okay, that means material we have to subtract the material from the raw material to attain the our required shape. That is the definition of subtractive. Then next one important, formative process. So formative process, what are the process you study in the production technology, like foundry, or drawing process, or whatever drawing process we studied, again forging, whatever process we studied by using this pungent dye, that all comes under the formative process. Okay, sheet metal, this all comes under the formative process. And another one important present day growing technology is additive manufacturing. So what is the additive manufacturing? Adding the material layer by layer, that is called the additive manufacturing. In the name itself, it is there the answer. Okay, so first one is subtractive in the sense, from the raw material we have to remove and we can attain our required shape. And formative, based on the pungent dye, we can apply the force from the outside. Okay, then we will be based on the pungent dye shape, you will be attain the your required shape. That is formative. Okay, blanking also it will come. Then next one, additive manufacturing, adding the material. Okay, here there is a three important one. When you are comparing with these three process, there is a lot, one important advantage is there in the additive manufacturing. What is that? Here material wastage is more. Okay, material will be wastage is more in this, because we are removing the material from the raw material. Okay, so whenever you are removing the material from the raw material, whether the shape is coming or not, we don't know. If it is not coming, the entire process, that entire material, raw material, we have to keep it in the scrap only. So here more material losses will be there. Okay, material losses will be there. Coming to the formative also same like that. Material loss will be there. Okay, again finishing operation. Finishing operation, that means surface finish. For surface finish purpose, we have to do lot of operation for the formative process. Okay, for example, if you are doing any casting, so after completion of the casting, we have to do a lot of post processing for the getting the good surface finish. But coming to the additive manufacturing, here only we are adding the material for to required to attain the our shape. Na? So no need to waste any material for this process. So material wastage is very less compared to the remaining two process. That is a very big advantage of our additive manufacturing process. So because why I am telling here very strong in the sense, because in entire manufacturing industries they are doing lot of cost cutting process. Okay, so during the cost cutting process, where they are spending the more money, that is in raw material side. So they want to minimize the raw material and minimize the process, then they will get the good profit. That's why they're nowadays all the maximum manufacturing industry they adapted to additive manufacturing. Okay, so coming to the next point, what is additive manufacturing? What is additive manufacturing? So now I am going to say another one thing. So there is a relation between the previous means this slide, industry revolution slide, and this additive manufacturing slide. Okay, so industry revolution, before we are in now fourth industry 4.0. How it will be uh, related to the additive manufacturing, that I want to say here. So additive manufacturing, it will be totally run because of the commands and softwares only. So whatever design we are making by using any kind of software, any drafting software, from that software or from that design we can able to convert directly to the production. Okay, but any other if you are seeing any other method like a subtractive or any other formatting method, not like that. After making completion of our design process, we have to buy the raw material. From the raw material, lot of initial process it is the pre-process there. After completion of the manufacturing process, again we have to do post processing, like that. So many different types of process is there. But coming to the additive manufacturing, not like that. Raw material, once if it processed directly, we can feed the raw material into the machine, we will get the final object. So that's why it is directly supporting to the industry 4.0. Okay, industry 4.0. This is very important here. Okay, so then now we can see about the what is additive manufacturing. Already I said in the name itself it is there. Additive means adding the material, we will get the final shape. So fabrication method which parts are built by adding material layer by layer under computer control using data from CAD model. So already I said, from the model, whatever drafting if you are doing, from the drafting we can able to convert easily. Already I said. So this is very important. And layer by, what is here layer by layer, sir? Layer by. So for example, you can see I want to complete final product like this. This is my final product. So I can't be able to make the final product as it is in the first step. Okay, for achieving this particular shape, I am going to deposit the material like this, layers. You can see the layers like this, layer by layer only I can able to deposit the material, and I will get the final shape like that. How the layering will be happen, you can see in this step. Okay, so this is, you can you can take as a assume as a nozzle. From that nozzle we can pour the material like this, layer by layer, and you can achieve final object like this. So what is this, sir? This is my CAD model. From that CAD model I am sending this file to our 3D printer supporter, or that means that particular machine will be support some format only. That format for changing purpose I am sending this developed CAD model to another one software. That software, we have a lot of software, but that software should be support to STL file. That should be support to STL file. What is mean by STL? Stereolithography. Stereolithography. In that file, after converting to STL file, we can able to give the commands like slicing. After making the slicing, so slicing in the sense layer to layer, we have to separate this particular object. Okay, this is our final product. In this final product I want to make like this layers. So this layer, sir, how much thickness I have to give, sir? That is based on the machine capacity, we can give the layer thickness. That is not a problem. That is each and every machine having different configuration. If you want to more surface finish of the product, you can give very less amount of or very less thickness of layer thickness. And if I don't want to bother surface finish, I want final product on time in the sense very less time I want to make my product, means you can give more surface thickness also. Okay, so this is the second step. And from the second step, here I am checking, I am doing the slicing method. After that, after slicing, I am sending that particular command to the machine. That machine will be print like this. Okay, that machine will be print like this. So layer by layer it will be print. You can see here first step. After that it will be add next layer, like that it will be add. So okay, after completion of this layering, I will get the final product. Okay, this is our objective, or this is our aim to produce that final product. I will get like this. Okay, so this is the additive manufacturing definition. So first we studied about the what is that fundamental industry revolution. Okay, so here 4 different types of revolution happened up to now. So one is industry for 1.0. So during that time, some small mechanical mechanism, by using the mechanical mechanism, some product steam power was developed, and water pump, like that things were happening in the industry 1.0. And the next level, that belt conveyors, by using the belt conveyors and rollers and pulleys, they made the industries. For this all things you can use to for only material handling purpose, but there also machine controlled purpose we used to human only material handling only happened by using the conveyors belt. Okay, next, third industrial revolution. The third industrial revolution, what are the things happened, I explained very deeply. And after that, from the third industry 4.0 was happened. So in that 4.0 I clearly explained what are the things was happened in that 4.0, what are the things is happening, whatever things is happening the present industries, this all comes under the industry 4.0. And the degree of complexity is increasing from the industry 1.0 to 4.0. So next, what are the different fundamental manufacturing or fabrication processes there I explained. And in that, first one is a subtractive, another one is a formative, and last one is the additive manufacturing. So what is that subtractive and what is a formative, that I explained very well. You can go through it. And next one is additive manufacturing definition. Okay, what is additive manufacturing? Then next, data flow of the basic AM process. AM is nothing but additive manufacturing process. So here I said, so from this first step, second step will happen, second step what is will happen, and third step what will happen, and fourth step what will be happen, I explain here. Here, by using the pictorial representation, I am going to explain. So first step, what is the first step? To making the 3D model by using any software. Okay, that is a CAD modeling, 3D CAD modeling. So here one thing you can remember clearly, here we are going to do only 3D object. Okay, compulsory thickness should be there. 2D object we can't able to make. Okay, only 3D. So 3D modeling only we have to do. From the 3D modeling, after completion of the 3D modeling, we have to save that file into the STL. Already I said what is the STL. Okay, nowadays all the software having this package, STL package. So easily you can save as if you are giving the save as command, automatically it will be show what are the different format it will be supported by this particular software. So in that we can select STL. So after converting the STL, that STL we have to send to the that particular software. So STL supported software is there. Okay, so Cura, best example is Cura software. Okay, so after sending this software, this 3D model, 3D design to the particular software, there we can able to see the full diagram of our design. There we can check any closed or unclosed, sorry, any unclosed elements are there or not. Unclosed in the sense nothing but, for example, you can see this is the square cube I am drawing. Okay, so here, so this backside view is a hidden view, but this particular hidden view also should be completed. Otherwise, it will be become the error. Okay, so like this, any unconnected edges are there or not, we have to check in this particular step. Okay, if it is there, we have to fix that particular problem. How to fix that problem and everything we will see in the upcoming module. So first we have to check. So if it is there any problem, we have to fix that problem. After fixing, then we can start to the slicing. Okay, slicing into the layers. Okay, so same previous diagram we saw, same like that. So suppose if you want to make this like this cylinder, we can give this based on this so total height is 20 mm. So 20 mm, and I am going to give the surface each layer thickness is 0.5 mm. Like that means, so 20 divided by 0.5, like that we have to give. So total number of layers it will come based on the same, like that we have to give, and we have to split it. Automatically software will give this calculation at all. We don't want to do. If you are giving particular thickness, so I want to make each and every layer 0.1 mm only, because I want good surface finish product. Time is not a problem. Like that, if you are feeling, we can give here 0.1 mm thickness, layer thickness, then automatically the slicing will be happen. After slicing, this will be this sliced software or software will be go to send that particular command to the machine. Okay, your 3D printer, it will be sent. So after sending this file to the 3D printer, the printer will be start to generate the G codes and M codes. That's why first I said clearly here, important, very important is the CNC and the NC programming, because based on this NC and CNC program only, this 3D printer will be run. Okay, so x-axis or y-axis, there also x, y and z axis will be there. So this 3 axis is controlled by same like the CNC G codes and M codes only. Okay, already you know what is G codes and M codes. So based on that only it will be produce our product. So after completion of the total product development, we can remove the product from the machine. So here some new word is there, support structures. What is the support structure, sir? So support structure, I will tell next model. I will tell in the detail, but just you should know something. So I am going to make like this one element. That element, it is a totally hollow, but the thickness is very less thickness is there. Okay, very less thickness is there. So this hollow, while making the printing time, maybe it will be get some damage in this particular place. For to avoiding the damage, I am going to make one structure like this, one support like this. Okay, after completion of the total product development, I can able to remove this one. So this particular step is called as support structure. So like that, any support structure, if you are given your object, then you have to remove in the post process. That is only remove a support structure, and you can go for post processing. Post processing nothing but, suppose if you are your product, final product, developed product having less amount of surface finish, we have to do some surface finish process. And any like this support structure removal process, if it is there, that also comes under the post processing only. This kind of small work we have to do means, then we will be get the final and our aimed product. Okay, so this is the data flow of the basic additive manufacturing process. So here you can see one more small flight. Okay, this is the first model. That means I'll say, so here you can see rapid prototyping, 3D printing and additive manufacturing. So here rapid prototyping is nothing but this kind of model making only. Okay, so this kind of model, in the sense final product will be made by some other big machineries. Okay, but before making that model, I want to do some testing. For the testing purpose, I can able to make small products like this by using the 3D printer. That kind of model if you are doing, that is called as rapid prototyping. For example, in that olden days, if you are seeing bridge construction or any big temple construction time, if you are seeing some movie, they will show this is the final product, like this will come like that. Small box they will make, inside the small box, that entire product how it will become, like that they will explain by using some virtual model. Okay, sorry, by using some physical model. So that is only called as the rapid prototyping. Okay, then coming to the 3D printing. So this is the first made first this flight jet is the first made prototype. That is a prototype supersonic aircraft by our Indian Army. And so difference I'm going to say now. So already I said what is rapid prototyping and what is 3D printer or 3D printing. So 3D printing is nothing but nowadays if you are going to any small stationery shop, you can able to see some small keychains or any flexible element or small toys. These all things we can able to make by 3D printing. Okay, 3D printing. So there is a difference between rapid prototyping and 3D printing. Okay, rapid prototyping means if I want to show my idea to the my teams or my colleagues, I can able to make small product or same sample like that. Okay, some scaling you can do and we can do the printing. Then that is comes under the rapid prototyping. Okay, then 3D printing in the sense that original product only, but the small products that all directly we can use. For example, keychain. If it is a small product also we can able to use as a keychain, and the small toys. So this all comes under the 3D printing. And then what is additive manufacturing, sir? Sir, additive manufacturing mass production. So for example, engine block is there, or total engine is there. That engine total things. So nowadays we are that engine four cylinder engine. That means the car engines are made by casting method. But I want to replace the casting method by using the additive manufacturing. Is that kind of production it will be comes under the additive manufacturing. That is a difference between the three things. Okay, so many people don't know about the what is rapid prototyping and what is 3D printing and what is additive manufacturing. So many people used to say these three are same like that, but there is some three are same only, but there is some small difference between the three things. Okay, so you can see here that tabular column, primary goal, prototype creation, already I told, and small scale small scale production, 3D printing, and coming to the additive manufacturing, mass production. Okay, then scope only for prototyping. So subset of additive manufacturing, then additive process. Okay, material variety, limited, moderate, and extensive. Already I told what is why sir here limited material varieties they given. So here sponge like that material only they used to make for like this prototyping, rapid prototyping. And moderate in the sense plastic material, normal plastic. If you are seeing the any tie or keychain, it will comes by plastic materials only. So that's why it is given moderate. Then extensive means all kind of materials we can use for additive manufacturing. Okay, for example, if you want to make by using titanium or titanium alloy, by using the same titanium alloy, you can able to make the product development by using this additive manufacturing technology. Okay, so precision moderate and varies consumer grade to higher precision and industrial grade. So if I am going to make any engine development product or engine product development, it should be meet industrial grade. Otherwise, I can't able to use that one. So it should be maintained by additive manufacturing technology only, not for rapid prototyping, not for 3D printing also. So these are all the main difference of three different process. So summary of this particular three types. First one is rapid prototyping. This focus on rapid creation of prototypes for evolution. Okay, so why sir here evolution in the sense? So already shown this diagram. So I want to make same like that on supersonic aircraft. So initially, if I'm making starting, if it is any failure will be happen, the entire my cost will be waste. For the small product I will make and I will show to my team or my colleagues. So for that purpose, if you are using, and you can able to use for evolution, that means, so this is the scale reduction process. This is called as a scale reduction. For the final product maybe 100% means we can able to make a 10% scale product. Then we can, by using that one, we can able to explain. So this wing will become up to this much length. This front nose will become this much. Then front back tail will become this much back length. That kind of things we can explain in the that kind of things we can explain by using rapid prototyping. Okay, next is the 3D printing. So 3D printing, already I said, the specific method often were both prototypes and some functional part. Functional part is nothing but some plastic, already I said, toys or something. So then suppose some player we can use this 3D printing for pattern development also. Okay, punch die is there. In the punch die development or pattern development purpose also we can able to use 3D printing. Then additive manufacturing. This overreaching term industrial application and investing precision and high quality manufacturing process. So whatever process you studied in the manufacturing or fabrication process, that all things we can able to do by this additive manufacturing. This all comes under industrial standard only. The same industrial standard we can able to produce by using the additive manufacturing. Okay, here is a different diagrams. You can see first diagram rapid prototyping, second image is represented 3D printing, and third is the representing the additive manufacturing. By seeing these three diagram only or three images only, we can able to understand easily. So what is rapid prototyping? See, he is making in that computer, he is making some car parts. Okay, so how the car and how that shape will become, he want to show to their teammates. That's why he is making one small part here. Okay, next one, 3D printer, 3D printing by using this plastic material. Okay, these filaments will be there. By using the filaments, it will be create. So this is you can able to create like small toys, like that things we can use, or keychains or any small pattern we can able to make. So this comes under the 3D printing. And third one, additive manufacturing, you can see here. So they are making here, you can see that industry is making very big one engine. Okay, so this all comes under the additive manufacturing. The pictorial representation, it is showing difference between rapid prototyping, 3D printing, as well as additive manufacturing. So up to now we studied about basics of what is additive manufacturing and what is industrial revolution, and the fundamentals of additive manufacturing and workflow of additive manufacturing, and difference between the rapid prototyping and 3D printing as well as additive manufacturing. So next class we will see types and applications of additive manufacturing. Thank you.